Okay, number 8, enter the equations of all vertical asymptotes and then enter the x-coordinate of any holes in the graph. So a hole is a new thing, we haven't talked about it yet. It's when factors cancel out. So holes are when factors cross-cancel. When you see the same factors, that's a hole. So in order to see holes, bad news, you got to factor. Sorry. So we have to factor the numerator and the denominator. So we're going back to factoring from quarter one. That's why we did that, because we have to know how. So first step when you factor, look for a greatest common factor. So all of these divide by a similar factor. Well, 16 is 2 and 8 and 4 and 4. I started with the smallest number. That's why I went to 16. If you're like, why'd she go there? It's the smallest number. So greatest common factor, do these all divide by 8? 36 does not. Do they divide by 4? Yeah, so the greatest common factor is 4. I'm going to take it out. 36 divided by 4 is 9. 48 divided by 4 is 12. And 16 divided by 4 is 4. So what this does is it makes the numbers smaller when we're factoring. So x does not equal, or a does not equal 1. That means we have to factor the long way. Sorry. So you multiply 9 times 4 to get 36, and then you're breaking this up. So we want factors of 36. The add or subtract to 12. So 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Do you see the winner? 6 plus 6 is 12. So I'm going to rewrite this 9x squared plus 12x plus 4. And I'm going to rewrite the 12 using the 6's. So 6x plus 6x. And then we call this factor by grouping. So I'm going to group the first two, group the second two, and again, we're going to do greatest common factor again. So 9 and 6 both divide by 3. They both have an x. So we're going to take out the 3x, and we're left with 3x plus 2. Same thing right here. 6 and 4 both divide by 2. So I'm going to take out a 2, and we're left with 3x plus 2. When these are the same, you know you did it right. There's a lot of the same on this one, actually. Our first factor is 3x plus 2. And our second factor is this one that's the same, which also happens to be 3x plus 2. And then we still have this 4 on the outside. So there's our factored form. The top is now 4, 3x plus 2, 3x plus 2. Okay, denominator factor is a lot easier. What do these have in common? Well, they both have an x, and they both divide by 2. So I'm going to take out a 2x, and we're left with, hey, 3x plus 2. 6 divided by 2, 4 divided by 2. So our denominator is 2x, 3x plus 2. And that's our whole, where these cancel out. But first, let's write our vertical asymptote. We actually have 2. We take the denominator, and we set it equal to 0, and then solve. And it's way easier in factored form. So 2x equals 0 is the first factor, just not in parentheses. And then 3x plus 2 is actually, we actually shouldn't do that yet. I'm sorry. If we solve that, we're going to get an asymptote, but it's not an asymptote. It's a hole. These can cross cancel. They should have had these switched. You want to find your holes first and then your asymptotes. So our hole is this factor, 3x plus 2. So we're going to set it equal to 0 and solve. There's our hole. X equals negative 2/3. And then our asymptote is just this one. So x equals 0. And I'm going to graph it so you can see what's going on. So 36x squared plus 48x plus 16 divided by 6x squared plus 4x. Kind of a crazy graph. So here's our asymptote, x equals 0. And then I was about to make our asymptote x equals negative 2/3, but that's not an asymptote. See, it goes through the line. That means it can't be an asymptote. But at x equals 2/3, we have a hole in the graph, which means the hole just goes along and then it jumps. Sometimes when we draw it, we'll draw it like this. We'll draw the line going down and we'll literally draw a hole and then continue it. So x equals negative 2/3 is the hole. Find that one first and then go back and find your asymptote.